through and graph 3 different examples. The first one is x minus 3 over x plus 2. And, oh, let's see. I'm going to do that. Let me add some space. Let's talk about this graph first. We know that there's a vertical asymptote at x equals -2. Because the degree of the top and the bottom are the same, we look at the coefficients here to get our horizontal asymptote. And that'll be at y equals 1, because I'm looking at 1 over 1. The x-intercept is going to be from the zeros of the numerator, so that's from the point 3, 0. And then the y-intercept is going to be when we plug 0 in for x. So 0, -3 halves. So we've got quite a bit of information here. We can look at the behavior near the asymptotes. So if we plug in just to the left and just to the right of -2, so we're going to look at f of -2.1, that's on the left, and then f of -1.9, that's just to the right. When I plug those in the numerator, if I plug -2.1 in, I'll get a number that's negative. And if I plug -2.1 in the denominator, I'm also going to get something that's negative. So overall, that asymptote is going towards positive infinity. Right. When I plug -1.9 in, the numerator will still be a negative number, but the denominator will be a positive number. So that asymptote will be going towards negative infinity. All right, putting all of this together in a graph over here. We have an asymptote at -2. Let's just do this like this. And then also at y equals 1. So like this, right? And then based on what I saw with the asymptotes, let's see, where are my intercepts? 3, 0. Let's graph that point. 1, 2, 3. And 0. Oh, sorry, that's wrong. We want to do 3, 0. 1, 2, 3 here. And then -3 halves, that's right. So like about here, right? As I am on the left-hand side of the asymptote is through the middle. The graph is going to be going up towards positive infinity. So it's going to be going up here. And on the right-hand side, it's going down towards negative infinity. Those two bits of information kind of match up with what I have here, right? Because I've got the two intercepts down here, and so then this part of the graph is going to look like this, sort of sandwiched in between the asymptotes there. Again, you can use Desmos to kind of just, make sure that your thinking is correct. All right, let's add some space here so that I can graph these others. A little bit of extra space, and I just copied that second function down below. Let's find the horizontal asymptotes first, which are the zeros of the denominator. The denominator factors into x plus 3, x minus 3, right? So we have horizontal asymptotes at x equals 3. Sorry, this is vertical. X equals 3 and x equals negative 3. The horizontal asymptotes, in this case, both of the degrees are the same also. So we look at the coefficients. That first, the top is sort of misordered, right? There's technically a negative 1 here and a 1 here. We're looking at the leading coefficients. So our horizontal asymptote is going to be negative 1 over 1, or it looks like it'll be at y equals negative 1. X-intercept, when does the numerator equal 0? We have 8 minus x squared equals 0, or 8 equals x squared. So x is going to be plus or minus square root of 8, or 2 square root 2. So we'll have 2 square root 2 comma 0 and negative 2 square root 2 comma 0. Here's our x-intercepts, and here are our asymptotes. And then the last part is our y-intercept. And so we'll plug 0 into the original. What do we get? We get 8 over negative 9. So 0 comma negative 8 over 9. Put all of those components together to get a graph. So first I'll do my asymptotes, one at negative 3, and then one at positive 3. And then we said the horizontal asymptote was at negative 1, y equals negative 1, so like this. Okay. We have intercepts. Plugging this into a calculator, we get about, this is about 2.8. And so this would be negative 2.8. We just need to know where to graph those. So about here and about here. Those are our intercepts there on the x-axis. And then y-intercept negative 8/9, so it's going to be down here, really close to the asymptote. Okay. So what we do then, again, is we figure out, we plug in points just to the left and to the right of the asymptotes. So I'll plug in a negative 3.1 here and a negative 2.9 here. Here I'll plug in 2.9 and here I'll plug in 3.1. Again, I'm going just to the left and just to the right of each asymptote to see what the behavior is. I'll save you all of the details, but what ends up happening is you get negative here, positive here, positive here. And again, I'm just looking for what's the overall sign. If I plug everything in, do I end up getting a positive number or a negative number? Because I'm going to use that information to help me draw the graph. So because I'm getting a positive number on the interior of both of those, I'm going to know that the graph is going up here and it's going up here. And then on the outsides, I'm getting that the graph is going down here, right? So what's happening is the graph is looking like this at these 2 points on those sides. And then here it acts kind of like a weird, really flat parabola like that. All right, one more example. Our third example, we'll look at x squared over x plus 1. We know that we have a vertical asymptote at x equals -1. As far as the horizontal asymptote is concerned, the degree of the numerator is 1 more than the degree of the denominator, so we know we're going to have a slant asymptote. So we need to do long division to figure out what the equation of that line will be. So x plus 1 divided into x squared plus 0x plus 0. I have to put placeholders for the missing terms. I'll put an x here, so then I get x plus x squared plus x. We subtract both of those values, and then we have a -x plus 0. So I'll multiply by -1. Then I have -x minus 1. Again, we subtract both of those values, and I have 1 as a remainder. We don't really care about the remainder in this particular case, because what we're trying to do is find what the equation of the line is for the slant asymptote, and it's the quotient. So our equation will be y equals x minus 1. All right, the x-intercept is going to be zeros of the numerator, so it looks like it'll just be 0, 0. And then the y-intercept it's going to be 0 over 1, so also 0. What's the behavior as we get close to the vertical asymptote? What happens if I plug in -1.1? That'll be just to the left of the asymptote. Or if I plug in -0.9, that'll be just to the right of the asymptote. And I'm looking at the vertical asymptote to figure out what the behavior is on the left and the right. I'll have something positive in the numerator because it's squared. That'll be for both of them, right? And in the denominator, for the first one, I'll have a negative number. For the second one, I'll have a positive number. So I know that the graph is going down towards -infinity on the left and up towards +infinity on the right. Okay, let's put this all together here. My vertical asymptote, my first one is at -1, so let's put that here. I'm not going to be very precise with this graph. Actually, I need to. Let me make this more precise here. Because we have to graph, so -1 is going to be here. The other line we have to do is x minus 1. So -1 is the intercept, and then it has a positive slope of 1. So it's going to look like this. Right, you just use y-intercept and slope to get your other asymptote. It's a slanted line. We know that the intercepts are at 0, 0. And then from our asymptotes to the right of the vertical asymptote, we know that the graph was going up towards +infinity. That was here. And then on the left, it was going down towards -infinity. That was here. So this kind of makes sense. The graph is going to look like this. It's sort of sandwiched in between these awkward asymptotes. But this is what it looks like. All right, another example of something that happens is when you have two terms that end up canceling one another. And if we were to just graph this final version, it would look like the graph that you see in red that's drawn here. But because the original had a factor that has been removed, And the number x equals 2 cannot be plugged into the equation. It's not part of the domain. We instead put a hole at that particular point. To figure out what the y coordinate that's associated with it is, you go to the version where the common factors have been canceled. And if we plug 2 in to this version here, we'll have 1 over 3. And so that's how they're getting this y coordinate to figure out where the whole of that particular graph is. There's no x-intercept in this graph because when we look at the final version, the numerator can never equal 0. The y-intercept is at 1 if we plug 0 in for x there. The x-axis is acting as an asymptote because the degree of the denominator is more than the degree of the numerator. And then we have -1 for that vertical asymptote. And that's the last example. So we've talked about slant asymptotes, horizontal and vertical asymptotes, and then this final example is if there happens to be a hole in the graph. All right, thanks for watching. I'll see you in class.